This is the second part of our Icom IC706 PLL fold. Okay, so the owner decided to go ahead with this board, and so I have ordered the needed parts, especially here our DDS chip, which is completely done, and then of course our little coils, which we found open. So that means we gonna install here our new DDS chip, and let's see if we can get this function back, and if after that our unlock condition is good again. Well, last time we discussed that this little voltage regulator must have been replaced together with these both resistors down here, and so we do not really know what has happened here and why this regulator has been replaced, but this regulator is simple for our both ICs here, and this IC we have found in our last video was completely shorted out, and we found that this little inductor, which is in the 5-volt supply line, has gotten higher resistance as it should. So there is a potential risk that this IC is faulty as well. So this is a little bit a blind approach, because well, we will first see what the result is when we have replaced this one. Okay, so let's go and let us fit in here our new DDS chip, and then we can see what it holds, what we are gonna get as a result. Okay, and as always we have cleaned here the pads so that we are able to place our new DDS IC down here, and yeah, so let's go ahead. Okay, so let's start here with our new IC. So of course we have to place it in the right way, and as we can see, our dot is down there, and there we have to place our little dot, not the both bigger ones. So the smaller one here has to go down in that area. Yeah, and of course it has to line up properly, and that is a very important step, so that we really have it here as we need it, and then we have to tuck it here at 2 points so that it is fixed, and we really can start soldering it down. Okay, so let's try that we can range it. Let's see. So now the most important part is, as I said, we need to tuck it down. So let's try how we can do it best. I hope that is okay. Maybe a bit more here. Yeah, so that looks quite nice, so it don't need to be pretty for the moment in time. So for the moment in time it is important to get it somewhat down here, that it is fixed and can't move any longer. So that is most important right now. So let's see, I've not the best view here. So once again, let's see. Okay, is it still okay from the orientation and from the alignment? And well, yeah, I would say it is okay. Good. So now, of course, what we need to do always, we have to apply flux, and maybe we start down here, so that might be okay so far. And let's see what we can do. Okay, looks good. And of course we have too much here, but we're gonna fix it later. So let's simply go ahead here first, and we can drag it here, as you can see. And we have already finished here our first pins, and so we walk around, and yeah, let me do that off camera, because it is always a little bit difficult to work around the camera. And so you've seen how it can be done, and yeah, so the rest I will do exactly the same. And yeah, so I will be back when I have finished the solder work. Okay, and the solder work is ready so far, and of course now we have to clean the board here and make it all nice and ready to go ahead. Okay, so our next step is that we change here this both inductors out. So we know that both are faulty. This one is open, and this here is a higher resistance, which we do not want. And yeah, if we have done that, we of course can go ahead and can put the PCB back into our radio, and then we of course can check the function. Okay, all is ready, and now I'm going to put it back into the radio, and then let's do our first check. So okay, the board is back in, and I'm finally ready for testing. So the radio is connected to the power supply, and yeah, we can start. And first of all we switch the radio on, and I keep the current under control here. So it is important that if the radio will draw current, then I mean excessive current, then I immediately have to switch off. So let's see. Current is fine, it is 1.3 amps, so you can see it here. So that is fine, no problem. And display came up, so no problem. and we have static, so that is nice as well. So the frequency generator is already connected here to the radio, but we do not have receive. So there is still something wrong. So let's check our parameters, that we see what's working and what's not. Okay, and first, so let's check our DC parameter. So that means our voltage behind the little coil which was open. So let's see what we have down there. 4.8 volt. So that is fine, no problem. And the chip is just a little bit, so I can feel that the chip is working. Obviously it is warm, but it is not hot, so that is a good sign. And then let's check the voltage behind our second coil, which we swapped out, and there we have 4.8 volt as well. So that is looking pretty nice. So there is definitely no problem. Now we go down here to our test points, which we did before. Yeah, just to remember what we did. So I tested the voltage down there. So this was our little inductor which was open, and I tested it here. So this both inductors has been swapped, and now the voltage are fine behind both of these inductors. So that is definitely good. And now I just want to know if we have here a signal, so that as we know is the DDS for our BFO, and we should have 9.01. so that is what we so you will see it in a second. So that is this frequency behind our DDS chip, which we has swapped out, and we want to know if our 9.10 megacycles for the BFO function is now present or not. And of course I can go down here, so because that is the output behind here, the filtering. And yeah, let me show the scope screen. Alright, so you can now see the scope screen, and let me go down here to our output of our BFO. Let me see that I can get down there, and yeah, here it is. So that is very nice. So you see we have output signal at our BFO, which is great. So let's see if it is the right frequency. I zoom in, and you can read it up there. So it is 9.01 megacycles, and that is exactly what we have seen in our block diagram. So that means the chip which we have swapped out, so our DDS IC down here in the radio is now back working, but still something is not missing, and is still missing. And you may remember when we did our diagnosis, we found that this chip here, and that is not a good sign, it is getting hot. So this chip here, our new chip, is warm, and that is operation temperature, but this chip here is, from my point of view, I mean, I do not burn my finger here, but it is really quite hot. And you may remember that this chip has also a malfunction, so we didn't see the DDS output as well, but we were not sure if due to the fault in this chip the processor may have switched off all the data information. So that was a question which we has to left open. And now we can check if our DDS function is back, because if it is not back, then we can be sure that this chip is as we said it before. I mean, that was on prediction a little bit, that most likely this chip has a fault as well, but it is always important to really make sure that the problem is there, and not that I mean, you can order a bunch of components and you can swap it all in, but that is something what makes a repair much too expensive. So it is really more fair to go step by step. And now we know this function is back given. Now let's check what's going on here. Well, and you may remember that we was able to test the output of our DDS here in the IC101 at this little transistor down here. So under this shielding we have our resistor network. This here is our filter, and down here this is our little transistor where we can test the DDS output frequency, which was missing last time as well. But let's check what we can see down here at this transistor. Okay, so let's start. And now, no, not now. Now I'm back here at our collector, and yeah, what we can see, there is definitely no signal, nothing at all. So let's see if our voltage controlled oscillator frequency is present here at our IC. So that is what we have done last time as well. And you see, yeah, signal is much too strong. Let's see that I reduce it here a little bit. Let's see if it is now fine. Yeah, look here. So this is our VCO output. So that means VCO is still running. And let's see if our reference frequency of 30 megahertz is still there. And here it is. So that is still there. But again, so that means for sure it is now proved this IC, the IC101, is faulty as well. Okay, and back to our schematic. So yeah, this here is our DDS IC, which we have swapped out, and now we have our BFO frequency of 9.01 megacycles. So this is back working, and partially we have a success because this is back running. Very, very nice. But now we still have a problem with our reference loop PLL, and that is our IC101. Yeah, let's see that we do not have here some problems. I zoom in here, and again, we do not have here the input from our DDS output of this IC, so we know that a portion of this IC101 has really a DDS output, and here is our DDS output, which should be present here at the collector to get fed in here in our ref in, and that is still not present. And that is, yeah, we predicted it a little bit last time, so therefore, yeah, I think still it was a good step to do our DDS IC first, this one down here, and now where we know this is working, the owner can decide how he wants to go ahead, because now we have minimum 3 options. So the first option is that the owner says, you know, now we really have to put too much parts into it, and that is too critical, so no, I don't like that, but maybe we put in a complete new PLL board. So that might be the first option. Of course, the second option is that we swap out this IC as well, but as I said, that is the main loop, that is the ref loop PLL circuit, this one here, and of course we have still our main loop PLL. And when we go over here, just for your orientation, this is our DDS, which we have swapped out, and here, this here, the IC461 is our main loop PLL, right? And now we can see here, this is a little coil we swapped out because it was open for our DDS IC, and we know that this here is the same supply line, and this supply line is also supplying here our IC461. So that means, yeah, in the worst case, this IC can be dead as well, and that means we have this where we now be sure that it is faulty, so this one needs to get swapped out, and maybe the IC461 as well. We will see it when our 101 is back working. So that still means this is the second option, and the third option, of course, I mean, the IC706 is an old radio, and well, there is certainly a point where you have to decide, do I really like to go ahead with an old radio where I really need to put a lot of money into to get it fixed, and then after a short while we have the next problem maybe on the power amplifier board or the main board. Or you may remember we also had a radio like this here, where all the filter relays were worn out. So that is what can be next. I mean, we never should forget this is an old radio, and yeah, therefore we really have to think about it very carefully. Once again, and that is what I already said in the last video, this radio can be repaired. And we see that our DDS function here for the BFO is back. So there is one problem less, and we can now swap this IC, and of course then I'm 99% certain that if we swap it out, that then here our DDS portion of this IC will be back as well. Then we need to see what's going on with our IC461. If we are lucky, all is fine. And but there is still the point which we have to consider. It is an old radio. So what will be next? And that is something, if you want to be fair, you really have to discuss all these options and all the risks which can be in this old radio. So therefore, these three options needs to discuss right now, and if we know what the decision of the owner is, we go ahead. If he decides, okay, we try it, then of course we swap here our IC101, and we hope that then our radio will be back working. But as we know, it can be that then we have another problem. So that means I have to stop the video right here. So again, a lot of I hope interesting informations you have seen in this video, and you see that sometimes it is not done in 5 seconds. So sometimes you really need to go step by step, and you have to discuss and you have to consider what will be next. So you see a complete process. So this is only an example to understand that you have to take as an engineer, you have to take a kind of responsibility. I mean, you can't always say, all right, come on, we swap this and this and this, and at the end of the day there is a huge bill, and that is simply not fair. And I'm the person who likes to discuss a problem with the owner, and that he really knows what he is facing, and that is the reason why I want to show you this process. Okay, enough for today. Thanks for watching, and catch you next time. Bye.